Welcome to the 112th video on misconceptions in physics. Okay, my name is Ratankar Rao. I teach physics in an international school in Bangalore, and my hobby is to do these videos. So, misconception physics is a set of videos which I got an idea from a few of my students, alumni, and my fellow colleagues who suggested that we should not only teach concepts, but we should also teach about when can these concepts go wrong just by analyzing. Just a moment, I think my voice is not heard. Okay, yeah. So just by analyzing the solutions or the problems with the mistakes which the students actually commit in their exam papers. And the result is that from the very beginning, I started with very few examples, and now together I've been making so many videos. And as of today, it has crossed 110 videos. This is a 112th video. So thank you, friends, for being with me in this journey and helping me out to suggest me about what kind of problems you need me to work on. So this is how it has helped me out. Okay, so without wasting our time, let us continue doing one more problem, so which is once again on a comparison video. Comparison problems are those problems wherein a concept can be applied to a problem, and we observe that it is something like uh, we have to find out a parameter, and this parameter will depend on some other parameters. Now, the question usually would be like, if you increase the parameter, like typically it would be doubling, tripling, or becoming a halt, and so on. Now, how does it affect the parameter? This is what is the question usually will be provided. So towards it, we have already done two such problems previously. One of the problem which we had done MCP1 was that we compared the distances when it moves in the same direction. For example, two balls of different masses are being dropped. How does the height depend on time? Okay, that's what we have seen in the first case. Then in yesterday's video, we have seen about how do you compare the velocities and accelerations. Velocity and acceleration does not change with respect to time. So again, here also, we looked at time only. Now, the next one, which we have seen here, which we are going to see now, is about how does the distance change or the height of fall in case of a free fall depends upon the velocity. Okay, velocity, when the velocity is doubled, okay, how does it change? Now, let us read this problem. A body falling from rest has a velocity v after it falls. Okay, this is not a. Okay, so this is typically one or two students have responded to this. So a body falling from rest has a velocity v after it falls to a distance height. So let us say once again, let me take up a building of certain height h, and then you drop an object here. It falls from rest, which means what? Your initial velocity is equal to 0. It falls from rest and it attains a velocity when it reaches to a height h. Oh my god, this is not the height h. It is this height h is referring to. When it has reached a height h, then this is the velocity. The distance it has to fall down further for its velocity to become double. Okay, now let us say, for example, it has to fall to some more distance. Somewhat, right? It has not reached the, okay, let me say, this is my height of the tower. Okay, it has fallen to this distance. Let me say this is some h2. Okay, so the question is, now what is the value of h2 for the velocity to double? Let us say at this point it has become 2v. Now this is the question. So blindly, what most of the students do is that they just say when velocity was v, the height was h. When the velocity was 2v, the height should have been 2h. Okay, thus the student response given to me is 2 times h. So 2 times h, which is incorrect. Okay, so we should not do these kinds of logical reasoning, but instead we need to work it out. See, always in physics, when some values are being given, not even values, okay, when even the values are not given, you are supposed to solve a problem by understanding it clearly and try to fit in the respective equations. Until and unless you don't put in the respective equations, you will not be able to solve this problem. Okay, now the question we have to solve here is that how is v dependent on h? Okay, so towards it, we use one of the equations of motion, which is v square is equal to u square plus 2as. Now u, what is u? Initial velocity, which is 0 here, 0 plus 2. What is a? A is nothing but you are dropping this one, and as a result of it, there's an acceleration due to gravity, which is minus g here. Let me write minus g. And then yes, what is s? S is nothing but the displacement. Now, if you observe, this is my positive x-axis, this is my positive y-axis. So this is my negative y-axis, negative y-axis. And hence you observe that this h will also be negative. So I'll write this as minus h. So thus I can write this as 2gh. In other words, v square is equal to 2gh, or v should now be equal to square root of 2gh. Okay, this is what we get. In other words, now we can say that v is proportional to root h. That's what we can say. Or you can, if you square this, I can write h is equal to h. Okay, or maybe I'll use the same equation. If you do not want this proportionality, some of them would have got confused with this y proportionality. Let us use with this itself. So I will just retain this equation and write v square equal to 2gh. Now, what is the question? Now we have attained, or we have now related the velocity to the height of fall. Okay. So this velocity is related to the height of fall. Now, if the velocity becomes 2v, now what should be the height? That's the question. So what should I do? I should just substitute the value of 2v here. So this becomes 4v square should now be equal to 2g into h2, right? This is the height h2. I do not know h2. I need to substitute. I need to find out in terms of h. So let me divide one by the other here. Why divide one by the other? Okay, fine. Don't divide. Okay. So if you get confused, what we'll do is, okay, we'll substitute for v square here. I just want to eliminate v square. That's why I'm doing it. So this should be 4 times 2gh. I substituted from here. For the value of v square, I substituted here. This should now be equal to 2g times h2, right? So now if I expand this, what will I get? 4 into 2g into h should now be equal to 2g into h2. So this 2g and this 2g goes away, and thus you get h2 is equal to 4 times h. See, totally you get a different answer. Thank you, friends, for watching this video. Thus, the answer here is not 2, but instead 4. So, if you really want to solve problems, you need to put your pen and paper, okay, while solving physics problems, and nothing comes just by guessing. Do not guess anything and try to work it out so that you get a correct answer. Thank you, friends, for watching. And if you like this video, do share and subscribe to my channel for more updates. Thank you.